Hi, I want to make a video about generics now that the latest Go 1.18 just came out a few days ago. And I think it's a pretty cool thing to make a video about a simple introduction to generics with the new version of Go. And as you can see, I already have here a two slices, one of floats and one of ints, and a basic program that prints the slices. Yeah, so they are not sorted as you can see. So what we do now, if we want to sort this, so basically I wanna show an example with the quicksort. I think it's a good example for generics because it's a simple algorithm that you need to write twice if you want to support multiple types. So at the moment it's not a big issue for us if we're gonna sort a list of ints or you will see now. So sort.int ints. So we have a list of ints and then we want to sort them. As you can see, they are sorted here. So this is no problem. It's just one line of code, so it works. The problem is if you need to support other types or multiple types. So at the moment you need to have two different function calls. That's one issue. So let's say that you want to sort this one. Okay, so floats. What do you do? So sort dot float. So there is no float 32 in the standard library. So one solution would be to just do this, okay, and it will work. Uh, but we cannot do that all the time. Maybe you can work with. You need to work with float 32s. Okay. So what we're gonna do is to implement a simple quicksort function. There is many ways to do it, more complicated ones, simpler ones, and uh, basically this algorithm is not so simple, but um, there is a few different ways to do the partitions. So for example, you have a pivot at the bottom, uh, pivot at the well at the I mean at the end or at the beginning. Okay, so partition. I will use the variable names from Wikipedia. This algorithm is very well known. So first algorithm is an array of int type. Start end is also int type and returns an int. So this basically this partition returns the pivot as you will see now. So pivot, sorry, pivot I is equal to a of end start minus 1 for j. You generally don't need to remember these algorithms unless you work in some research of algorithms because this is online everywhere. Takes nothing to find it and implement it in a way that works for you. Some interviewers can ask about this type of algorithms, but my experience is that this for very advanced things because nobody needs to know how to do this by memory all the time unless you work in some research of algorithms in particular. Because, for example, if you work in data science and things like that, you just find a sorting algorithm that works for you and implement it. So it takes nothing really. This function returns the new pivot. Okay, then we define a new function, which is the quicksort function, and we define it. Well, it's the same parameter, so we can just copy paste this. Okay, and if start less than end. But I think it's pretty cool is to understand how this works, this algorithm works, because that's a different thing. One thing is to memorize everything, and another one is understanding complex things. It has a lot of value, and it's interesting as a learning experience. So, p plus 1 end. So this already should work. Okay, let's try it. Let's remove these ones. Well, let's comment that out one moment. Now let's call quicksort. Int is our array, start at 0, len of int minus 1. There. So it works. I didn't mess it up. There it is. It's sorted. So the problem now is that if we want to call this algorithm we wrote, um, the different data type, okay, it won't let us. You see, it says only ints. So a simple way to do this now with generics, okay, is to make this function generic. It's so easy. So we add square brackets where we are gonna create a new, basically, uh, type that encapsulates multiple types. Okay, so let's call it T for type, and it will be int or float 32. You see, the syntax is so intuitive and simple. Okay, just square brackets before the parameters, name of the type that is gonna encapsulate multiple types, and the types one after the other separated by this. It means or. Okay. Now it's complaining that the quicksort function doesn't infer t. So what we're gonna do is just, well, first of all, we need to change the type of the array we are passing the slice. This is gonna be t. Okay, so basically we are gonna use this. The type of the slice is gonna be this one. Okay, and it's complaining that cannot use this one because int is not a valid argument to partition. Okay, so what we do is just copy this because it's exactly the same. Okay, and that's it. Everything works now. Let's just try this one. Floats 0. We wanna sort from 0. Len floats -1. Yeah, it's float 64. Okay, so if we do this, okay, we go here, it's gonna throw an error that the interface doesn't implement float 32. Okay, so basically what we want to do is to create an interface. Okay, so well, another way to do it is of course to just change this here, and it will work. See, it works. It sorted the floats. But that's not the solution we want. We want to basically create a generic thing. So we're gonna add a new interface. Okay, so type number interface, and it will be our way to pass multiple types to our constraint. Okay, so it can be int float 32 or float 64. Okay, and now we replace this like that, and it already supports float 64. Everything works. It can quicksort a float 64 slice. That's amazing. So basically we wrote some code to sort int numbers, integers, and now uh, we just changed the function definition there, parameters, and we already can sort float 64s and float 32s. And as you can see, it works because these are floats. And I think that's a simple introduction to generics and why we need them, and the way to implement it in a simple way. Of course, there is a lot more to generics, and I want to make more videos about it. But I think for a first video, I think is enough. So thank you for watching, and hope you enjoyed it.